Hello everyone, so in this video we will be looking at the lead code problem 2849, that is determine if a cell is reachable at a given time or not. So what the problem statement states that like we are given 4 points, so we are given sx, xy, sy, then fx and fy. So these are 4 points we are given like on a plane, and what we have to do is we have to find like whether we can reach from sx to sy, or we can start from sx to sy and reach fx fy in time t or less than t, right? So this is what we have to do here. So if you might have done some dp questions like from traveling from top to bottom or stuff like that, you might come into that approach, or a recursive approach of like marking visited and not visited, stuff like that. But let us just look how we can do it. So these were the approaches that came to my mind, but it was a simple math problem. So let us just create one matrix, I would say, like to represent the points. So in the first example, the points we are given are 2 4 7 and 7, right? So 2 4 will be over here, 7 and 7 will be over here. So and time is given as 5 or 6. Let's just have a look. So okay, so time is given 6, so time is 6. So we start from here and we have to go there in how many time? Okay, and from going from this box to this box, it will take time 1. So it will take 1 second or 1 minute, whatever you want to call that, that does not matter here. So in how many ways we can do this, like in how many ways we can reach there, right? So I can go from here win 1 time, then here 2 time, then here 3 time, here 4 time, here 5 time, here 6 time, right? And my t is 6, I cannot exceed 6, so I cannot reach this way, right? So I can start from here 2 3 4 5 6, I reach here, right? I can go like this, so it will again take 6, 1 2 3 4 5 6, right? So I have to, like, to minimize this, I have to like take some steps diagonally, then I can go on. So if I take like 1 2 3, I can take 3 steps diagonally at max here, and then I can do a 1 2 and I will reach here, right? And it will take 5 time 5, and which is less than 6. So this way I can do it. If we observe something here, like if I travel like this or either I travel like this, it will be same thing. The time taken will be same thing. Like, so how we will do it, we will just keep two things in mind. First, travel as much diagonal as you can. Travel as much diagonal as you can, right? Now second thing is, so if I travel as much diagonal as I can, you can go ahead and do for other test cases, like other scenarios and stuff. So 2 and 4, if I go here, I will go to 3 and 5. If I go here, I will go to 4 and 6. If I go here, I will go to if I go here, I will go to 5 and 7. 5 and 7. So at some point, either this x will be equal to one of them, or y will be equal, right? At some point they will be equal to either x or y. So after that, what I can do, I can just go down, or right ways, left ways, whatever it is, right? So that is something I can do. So first thing is to travel diagonal as much as we can. Then we have to figure out like how much left or right, like vertically or horizontally, I have to travel. So in this case, for 2 and for 2 4 7 and 7, I was traveling diagonal from 2 to 2 4 to 3 5, then 4 6, then 5 7, right? So I traveled from here and I reached 5 7. Now I am here in this column, I don't need to change this, but I can I need to go 7, 2 more steps to reach 7. So I moved 3 steps earlier, okay, 7 minus 4, 3 steps earlier, and then I'm also moving more 2 steps for this, from going 5 to 7, which will also be added, and it is 5, which is less than 6. So this way we can reach and return true, right? So let us just look how we can like do it. So first of all, what we are doing is, we are moving diagonally. So how much steps diagonal we can take? So diagonal steps we can take is 7 minus 2, 7 minus 4, right? Absolute, it will be absolute obviously, right? And the minimum of this, I can take minimum steps diagonally, like what will be the subtracted value from this, I will consider the minimum one. Because if I consider this maximum one, which is 5, I cannot move diagonally 5 and reach here. Like I will go somewhere around here, then I have to come back here. That will I in that way I will be traveling extra. I don't want to travel extra. I want to just be here in less than or equal to 6 times. So I cannot afford to go over, right? So first I can take minimum. So I can store in some variable like k the minimum of abs of sx minus fx and abs of sy minus fy, right? This is one thing I need to do. And after that, I also need to make sure like whether I need to move this one ahead or I need to move this one ahead, right? So how I can do that? So I will take a variable x1, I would say, and what it will be k. Now what we will be doing, I need to make sure like now I need to find this 2 becomes 5, and I need to like 2 more can be added, right? And this 4 becomes 7 and it will add 0. So I need to get these numbers. How I will do that? So x1 will be something like k, because I'm adding the diagonal distance I travel to this value, plus the minimum of sx or fx, right? Obviously I can like come, so I can like come back from here, but what we are doing, we are just moving towards the diagonal. So for example, if I am at this point and I am going to this point, right? So I will travel once diagonal, twice diagonal, and here in 3 steps. So from 4 3 we are going to 2 6, right? And we are traveling diagonal like this. So we are traveling diagonal like this. So how much steps we took diagonal? 2. So it will be 4 minus 2 or 2 minus 4, absolute is there, and 3 the minimum we are taking, right? And then what we are doing, I am doing like x1 value, which is equal to 2, plus I will consider the minimum of sx or fx. So it will give me 2. So x1 becomes 4. So that will tell us, okay, x has traveled the way it can. Like we cannot afford to make x go more further. So now, and x2 will be y1 will be 2 plus a minimum of these 2, sorry, 3 and 6, it will be 3. So y1 will be 5, and what it will say, 6 minus 5 is 1. It can say like, okay, we can make this y to go one step ahead. So that is what we are doing here. And similarly, y2 will be k plus minimum of sx minus sx and fx. This is what we are doing. Then we can get a temporary one, which will be x1 minus max of sx and fx. Then temp2 is y2, okay, y2 minus max of sy and fy, right? And in the end, I can return if the sum of temp1 plus temp2 plus k. So temp1 plus temp2 plus k is less than equal to t, I can return true, otherwise I can return false. Now there is some edge cases in this question, okay, and I think I should discuss them as they are quite tricky. So for example, I am here, sx and sy and fx and fy, both the points are here, right? And in I have given time 1, t1, okay. So in t1 I move here or any other side, okay, and next time I come back here, I will take 2 time, right? And if t is equal to 0, I am at 0 time, I am here only, so I can return true, right? At time 1, if I consider, I will go here, but I cannot return back, so time will be 2. So the edge case is if both the points are at the same location, So if sx equals to fx, and sy equals to fy, right? So in that condition, if time is equal to 1, then we will return false, because we will start from here, but and t will be 1 here. Next time we go back, t will be 2, right? So for 2 it will be true, for 0 it will be true, for 3 will it be true? Yes, it will be true, as at 1 I reach here or somewhere here, then at 2 I come here, I am here, and it is less than t, so it will be true. So this is one of the edge case. Now we'll if you dry run this on yourself, you will get a clear better understanding of this logic. Now I'll just code it quickly so you can see. So let's go to the lead code and do it. Okay, so here in the lead code, we are here in the lead code, and let us just code it. So k will be what it will be. It will be minimum of absolute of sx minus fx and fx, not fc, and absolute of sy minus fy, right? And after that, we were having x equals to k plus minimum of sx comma fx, and similarly int y equals to k plus minimum of sy and fy. After that, we were having some variables like in temp1 I will say, and it will be x minus maximum of sx and fx. Int temp2 will be x minus maximum of sy and fy, and in the end int answer equals to k plus temp1 plus temp2, and we will return if answer if answer is less than equal to t, we will return true, otherwise we will return false. And now let us go to the edge case. If sx equals to fx and uh, sy equals to fy, in this, if t equals to 1, just return a false, right? Else we will return true. So now let's just submit it. Okay, we get a wrong answer at this case, 13173. Expected is false. We might have done some. So we are getting a wrong answer because we have done a simple mistake here. It will be absolute, as if I say the points are the right. So x is diagonally how much a x point has traveled, right? So it is telling how much x point has traveled diagonally. So for example, s of x is 2 and diagonally we have traveled 3, so it will be 5, and we are getting an f of x is 7. So from 2 and 7 we are getting a 7 here, and we were not doing absolute, so 5 minus 7 will give me minus 2. That is why we were getting a wrong answer. So we will just add absolute here, and now we will submit it. So it should be submitted this time, and you should dry run it with different cases, and there is one more mistake I have done. So temp2 will be, we are checking for y here, so I am putting x there, so that was also giving me, because of that I was also getting a wrong answer. So if I submit it, it should be working fine. So I will just encourage you to run it on different cases, and you will get to know, like for example, if I have x1 and y1, right? I have some points, x1 y1 and x2 y2. So there are certain kind of I will say combinations, like x1 might be lesser than x2, and x2 might be lesser than x1. Then similarly for y1 might be lesser than y2, and then y2 might be lesser than y1, then combination of all these, you know so go ahead and dry run this, like on 2 3 examples, you will get to know, like the basic logic around this, like if you, then you will understand this problem better. So I hope to see you all in the next one, and I hope so you did enjoy this video. So thank you for watching, and do subscribe and like.